This is Terrell Pauly with Learn Healthcare IT. And what I'd like to do today is I'd like to actually start off with a series that's based on getting started with IT for beginners. And I thought about this because of before you get into healthcare IT or before you want to become a systems administrator or a network administrator, whatever type of IT position job you're trying to get into, of course, you need to know the basics. So I thought that I would kind of touch on some of the basics for individuals. This is for individuals that are looking to actually get into IT. They don't really know anything about IT. So this series will be a certain amount of videos that I'm going to do, and this the focus will be on for the audience is going to be for people who are trying to learn about IT, trying to get started within IT, beginners. So this is going to be beginners. So I wanted to lay that out ahead of time. So let's begin here. So when you talk about first getting started in IT, there are some items that we can get started with. So let's start from the very beginning. Okay, so in the beginning, God created the heavens and the earth. So in the beginning, just getting started. So when we're talking about, and this is going to be basically focusing on Windows operating systems. Of course, so for me in my career, my IT career, I've companies that I work for, been in relations with, as far as or had relationships with rather, they've all been majority of the time have been Windows-based operating systems. So my training, this series is going to be based on Windows operating systems. So let's just so when you're talking about supporting you want to try to get into IT. When you first get into IT, basically you're either going to be you're going to start off like within the help desk position, or you may basically like a help desk is more starting out role, help desk position, or maybe like a customer support specialist, something along that lines, a support specialist. So these are some of like the more of the common tools that you'll see when you have somebody that calls, and when they call it they contact you because they have an issue with their workstation, with their operating system. And we're going to start with, as far as this on the software side of things. So when you're talking about a laptop or a desktop computer, a couple of main components, right? So let's start it off from here. So you have your, of course, when you open up the Windows Explorer here, you have your C drive. You have whatever devices that you have listed here, and your C drive is your default is your main hard drive for your system. Sometimes people may have multiple hard drives. They may have just one. You can actually, well, I'll just stick with that right there. And so you have your hard drive. Main components of a laptop or a desktop is so you have the hard drive where your operating system is going to sit on top of, because if you actually click in here, right here is actually the Windows directory is where the actual operating system gets installed. Windows, and you have all your Windows folders and files and everything that's dealing with the actual just the software installation of Windows itself. So your Windows is going to be on your root where you install whatever hard drive you want to install Windows on. It doesn't have to be installed on a C drive, or you can call it whatever type of drive you want to. It could be called C, it could be called F, G, whatever letter of the alphabet. But the kind of de facto standard is you're going to want to start with the C drive. This is the C drive. It's the more common drives, where is your default drives. So with the hard drive, you also have, if you actually right click, let's go to properties here. All right. So if you go to properties, system properties on your laptop, on your computer, then you'll see some system information, right? So another main component of a laptop or a desktop computer, a workstation, is going to be your processor, and your processor is your main hub of where all of your actual commands are being actually carried out at. So any sort of command that you do, anything that is done on your laptop, on your workstation, from anything from actually opening documents, from running YouTube videos, whatever you're doing on your workstation, it's going to actually run through the commands. It's going to eventually run through and to your CPU, which stands for, what is it, Central Processing Unit? I forget. I believe it's Central Processing Unit. So your CPU handles all of your all of your actual tasks that you want, that you're telling your operating system to do. So your processor, CPU, is very important. Of course, it's the hub. You can't have a functioning workstation without your CPU. And so basically, this tells you the brand, CPUs, Intel, you got the model, and then you have the speed here. So you have the speed, which is 2.5 gigahertz. And that's the speed of your processor. In addition to your processor, your CPU, you also have something that's called your RAM, your memory, and which RAM stands for Random Access Memory, I believe. And so your memory is sort of, if you look at your memory is a place, your RAM is something that allows you to execute tasks faster versus, so let's say when you open up a Word document, so all right, so you open up Microsoft Word. What happens is, so you open up Microsoft Word, the OS is actually, it'll actually send the actual command to the CPU, execute whatever command that needs to run, and then you have the actual application or the program, Microsoft Word, resides on a hard drive. So so in order to actually launch, you actually have to, so what happens at that point is, there is a point to where, in order to actually, for Microsoft Word to be able to actually run, it actually, the actual program itself will actually run in memory on the RAM. So the actual execution of Microsoft Word and whatever you're trying to do, as far as creating a document, it'll actually run in memory. It'll actually run in RAM versus trying to go back to the actual hard drive to where the program permanently lives in order to carry out execution. So the RAM is kind of like a buffer to be able to go to in between to be able to carry out executions as far as whatever that needs to be done versus going back to the hard drive, because the hard drive is slower, much slower than actually RAM. So you could think of RAM if you need maybe like a better visual or something like that. So you could think of it as, let's say, if you're actually doing some cooking, if you're actually going to be doing you're cooking in your kitchen, and let's think about that for anybody out there who's a cook. You have to have your, what do you need to cook? You need to have your whatever ingredients that you're going to use. You have to have your, your main ingredients. You want to have whatever sauce is, um, whatever, I can't think of what I'm trying to say, but peppers, salts, whatever additional seasonings is what you want to put on there. You need your actual contents to what you're going to cook. What you need: a pan, you need pots, you need a you need a spoon, you need a knife, whatever you need to the actual hardware. So you have all these different components, and they all live in different places within the kitchen. So you have to go to the refrigerator and get this. You got this food. You have to go to the freezer to get this meat. You have to go to your cupboard on the left-hand side to get this seasonings, or you have to go to your bottom cupboard on the right-hand side to get your pots. So all these different pieces that live in it, they all live in the kitchen. So it takes time to be able to go, when you're just getting started, to go into all these different places to get all these different items, right? And then you put them, and you want everything that you need, you will lay it out on the kitchen counter to where you can get to it. So now, once everything is laid out, everything you need, you leave it there, and let's just say you leave it there and you go somewhere for half an hour. You got a phone call comes in, you take a phone call for half an hour, you come back, and you want to pick up where you left off. Well, now you have everything that's already laid out on the kitchen counter. So now it takes less time for you to actually be able to get you already have your ingredients. You already have everything that you need there laid out. So you can just get started, with you can get the rice, and then you pour it directly in. You have your pot. You could pour it directly into the pot on your stove. You don't, it saves you time. So you can think about the relations. Think about that relationship with the analogy between the kitchen and all the components to with the hard drive. So think of a hard drive as hard drive is all these, like your hard drive is like your refrigerator and your cabinet and your cabinets. And so in the RAM, your installed memory, your memory is actually like the kitchen counter, because now everything is actually everything is now actually laid out on the kitchen counter, and you're able to actually get started and do things a lot faster. So that's the analogy I want to use to how a hard drive relates to your memory. Every program, everything, including Windows, your operating system, all the programs that get installed on Windows, they all live on your hard drive. Everything's on your hard drive. So when you start up Windows, right? So Windows starts up, your workstation starts up. Windows will put itself into memory so it can actually, run and execute different tasks faster than versus having to go, run everything from your hard drive. So it'll run things, Windows will be able to execute faster from memory. Same thing with Microsoft Word. So Microsoft Word lives on your hard drive. So, but when you open it up, it will actually insert Microsoft Word would then insert itself into memory because you told your operating system, your Windows operating system, hey, I want to open up Microsoft Word. So your operating system will go, to the hard drive and execute a command, does CPU, whatever, executes the actual command to launch Microsoft Word, and Microsoft Word will basically come from the hard drive, parts of it into memory. So now, when you want to do something, as far as you want to type something, this is a test that I'm doing here, right? So you're typing this. So now Microsoft Word is actually in memory, so it doesn't have to. It'll be able to execute its tasks faster. So hope that kind of helps things to make it clear. So, and you can actually kind of see that if you, let's start again. So if you right click and actually go to your task manager, if you right click on your taskbar and you go to open up task manager, right, so you can see task manager shows you a lot of different things. It shows you all of your processes that you have running. It's one thing, and then you will actually see Microsoft Word here somewhere, right here. So this is Microsoft Word, right? It tells you what you have open, and it also tells you what the how much CPU that it's taking up. It'll tell you how much memory. So this is how much the Microsoft Word program has currently that's running in memory. And this way you can see the different programs and processes that are currently running on your workstation. Okay. So that's memory, right? And the more memory that you have, the better, right? Because the more memory means that the more that you can actually, your workstation can do faster. The more applications that can be run simultaneously on the workstation at the same time. The more processing that can be done faster, or the more executions that can be done. The more intensive stuff that you have going on your workstation, the more memory. Having more memory helps out with that, right? So because typically by itself, we could take a look at that, right? So let's take a look back at the task manager. So you'll see right here, so this workstation that I'm on, I mean, it's already, so let's just go to the memory. So right now, the memory, right now, 50% of my memory is being utilized. 150 megabytes is being used right now by what I'm using to actually record this video with. And then you have other stuff that's actually being used, accessing, that's taking up memory. And there's stuff that's being run in memory. Again, all of these programs and processes are being run in memory, so that because they're running in memory, it's a lot faster than trying to run from the hard drive, because the hard drive is a lot slower. Okay, so those are the main components of a workstation. All right, so you have your the hard drive. You have the hard drive. Remember, your hard drive is like if you go back to the kitchen analogy and you're cooking, your hard drive is kind of like your refrigerator, your cabinets. Everything's it's stored inside of these items. Your processor. Your processor is what actually does the execution. So I guess can be, if you're using that same kitchen analogy, maybe your processor is like I don't know. Maybe your processor is actually, in that analogy, maybe the person is actually the processor in the kitchen analogy, because the processor is actually performing a task that needs to be done. So the person is actually, going to the going to the kitchen and getting the items, putting them on the counter, um, going into the actual cabinets to get the pots and pans. So in this scenario, in this analogy here, the person is actually processor, which is the processor. The CPU is actually carrying out all of the actual tasks, right? The executions are being computated and run from the CPU, the processor. Okay, and then lastly, the RAM, your memory. Your memory is kind of like, well, they hang everything out on a counter. So your memory is like your counter. So you have everything out. So then you can execute stuff a lot quicker than having to go back into the refrigerator and looking and trying to find stuff, or going into your freezer and trying to find stuff. Your memory is kind of like your kitchen counter. So these are kind of like these are the main components of your workstation. So the more of a larger processor that you have, the more that you're able to execute, computate. You're able to actually, because your CPU is like the brain. It's the brain of your body. So the bigger the processor, the faster the processor, and the more that you're able to compute at the same time, the more that you're able to get done, the more that you're able to do. And I don't want to make this video too long, so let's see how long we're at here. Next, let's talk about a little bit more about if you open up system information, right? So in your system information, it'll give you a summary of your system. One thing I want to point out about your processor is, so your processor can actually have what they call now, your processor can have multiple cores and multiple logical cores. So a core is pretty much another processor itself. So like another physical processor. So on my laptop, I basically have 4 processors, right? And then what you can also have, and then I have 4 logical processors. So basically, now remember, what a CPU is, the brain, or it's the actual brain that actually carries out all the computations, everything that executions that needs to get done. That's what a CPU is for. It's your hub, it's your brain. Without your CPU, you cannot have a functioning workstation, right? So when you increase, you can increase the speed, of your CPU in order to make things faster. If you want to greatly increase the amount of execution you're able to do, you can just, it's kind of like doing like a parallelism, to where you are making another processor, so you can handle. So now your CPU can handle twice the number of executions they can get done, because there's twice the number of processors. So in this case, there's 4 times. So my CPU, versus having just 1 core, it has 4, so it's able to do 4 times of what it would have been able to do if it only had just the 1 processor itself, or the 1 core. If that makes sense. So now, in addition to that, the 4 logical processors. So each core is in itself, it's a logical processor. So by itself, it's a logical processor. So that's why I have 4. Now, some CPUs, they are able to do something that's called like multi-threading, to where each core can handle more than 1 thread at the same time. So let's say, for instance, for example, if my CPU, which is has four cores, let's say that my CPU is able to handle 2 threads per core. So it would be 4 times 2, which would be 8 logical processors. So because each core is able to do 2 threads, right? So that's what you do, 4 times 2, because four cores times 2 threads each per core, it gives you 8. So that would have been 8 logical processors. But for my CPU, I'm only able to handle 1 thread per core, and that's why I'm able to handle 4 logical processors. That's why I have 4 logical processors. In addition, so that's that. I wanted just to point out a little bit more in depth about that, about your processor itself. And we go back to Task Manager. I had to get me a faster laptop, or because this may not be able to handle what I'm trying to do here. It's already but let's see here. We go to, so your Task Manager has all your processes, your performance. If we click on performance, right, and it'll tell you, open up, if you have like Windows 10, I don't know when this actually started here. I don't know if it was Windows 8, Windows 7, I'm not really sure, but if you have this open resource monitor, if you have resource monitor on your Windows workstation, this will tell you, if you click on the CPU tab, you have an overview, but if you click on the CPU tab, this will tell you how many cores that you have. It'll display how many logical processors you have. So I have 4. So CPU, and it starts from 0, goes to 3. So 1, 2, 3, 4. So I have 4 logical processors there. Just wanted to point that out. Okay, so I think that's pretty much it for this. I just wanted to go a little bit more in depth about the different the CPU itself. So until next time, my name is Terrell Pauly. Take care.